Arc fault circuit interrupter, or AFCI, breakers are designed to protect against electrical fires caused by arcing faults. While 15 amp and 20 amp AFCI breakers are commonly used in residential circuits, there are specific situations where a higher amperage rating is necessary. Firstly, high-power equipment such as electric stoves, ovens, dryers, and air conditioners often draw more than 15 or 20 amps. For example, an electric oven consuming 3,600 watts at 120 volts requires 30 amps. In such cases, using a 30 amp or 40 amp AFCI breaker ensures proper circuit protection without nuisance tripping. Secondly, long circuit runs can lead to voltage drops, which can affect the performance of AFCI breakers. These breakers are sensitive to voltage fluctuations, and excessive voltage drop may cause them to trip unnecessarily. To mitigate this issue, a higher amperage AFCI breaker may be needed to compensate for the voltage loss and maintain reliable operation. Thirdly, circuits with multiple appliances connected can easily exceed the capacity of a 15 amp or 20 amp breaker. If several high-power devices are running simultaneously on the same circuit, the total amperage draw can quickly surpass the breaker's rating, leading to frequent tripping. A higher amperage AFCI breaker provides the necessary capacity to handle the combined load without overloading the circuit. Fourthly, circuits that supply mixed loads, including lighting, outlets, and appliances, require careful consideration of the total amperage draw. Each component contributes to the overall load in the circuit, and the AFCI breaker must be sized appropriately to accommodate all connected devices. A higher amperage AFCI breaker may be necessary to prevent overloads and ensure safe operation. Fifthly, heavy-duty applications in commercial or industrial settings often demand higher amperage AFCI breakers. Equipment with high power requirements, such as machinery and lighting systems, necessitate circuits capable of handling substantial current flow. In these scenarios, high amperage AFCI breakers provide the necessary protection against arcing faults while accommodating the power demands of the connected equipment. Calculating the required amperage for a circuit involves determining the total power consumption of all connected devices. Power, measured in watts, is related to voltage and current by the formula power equals voltage times current. By rearranging this formula, current equals power divided by voltage. For example, a device consuming 1200 watts at 120 volts draws 10 amps. To calculate the total amperage draw for a circuit, add up the individual amperages of all connected devices. When selecting an AFCI breaker, it is crucial to adhere to the National Electrical Code, or NEC, and local electrical codes. The NEC provides guidelines for circuit sizing, overcurrent protection, and conductor ampacity. Consult NEC Table 310.15b16 to determine the allowable ampacity of conductors based on their size and insulation type. The AFCI breaker rating should not exceed the ampacity of the circuit conductors to prevent overheating and potential fire hazards. It is also essential to consider voltage drop when selecting an AFCI breaker for long circuit runs. Voltage drop occurs due to the resistance of the conductors and increases with the length of the circuit. Excessive voltage drop can lead to reduced performance of electrical equipment and nuisance tripping of AFCI breakers. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger conductors or reduce the length of the circuit. Another factor to consider is the type of load connected to the circuit. Continuous loads, such as lighting and heating, are expected to operate for 3 hours or more at a time. The NEC requires that the overcurrent protection device for continuous loads be rated at no less than 125% of the continuous load current. For example, if a circuit supplies a continuous load of 16 amps, the AFCI breaker should be rated at least 20 amps. Non-continuous loads, such as appliances and tools, are not expected to operate continuously for extended periods. The overcurrent protection device for non-continuous loads can be rated at 100% of the non-continuous load current. When installing AFCI breakers, it is crucial to follow the manufacturer's instructions and ensure proper wiring connections. AFCI breakers have specific line and load terminals that must be connected correctly to ensure proper operation. Incorrect wiring can result in malfunction or failure of the AFCI breaker. It is also important to test AFCI breakers periodically to verify their functionality. AFCI breakers have a test button that simulates an arcing fault and trips the breaker. Regular testing ensures that the AFCI breaker is capable of detecting and interrupting arcing faults. If an AFCI breaker trips frequently without an apparent cause, it may indicate a problem with the circuit or the connected equipment. Common causes of nuisance tripping include loose connections, damaged wiring, and faulty appliances. Inspect the circuit and connected devices for any signs of damage or malfunction. If the problem persists, consult a qualified electrician to diagnose and repair the issue. In addition to AFCI breakers, ground fault circuit interrupter, or GFCI protection is also required in certain locations. GFCI protection is designed to protect against electrical shock by detecting ground faults. Ground faults occur when current leaks from a circuit to ground, such as through a person touching a live wire. GFCI breakers and outlets are commonly used in bathrooms, kitchens, and outdoor areas where there is a higher risk of exposure to water. The NEC specifies the locations where GFCI protection is required. It is important to comply with these requirements to ensure electrical safety. AFCI and GFCI protection are essential components of a comprehensive electrical safety system. AFCI breakers protect against electrical fires caused by arcing faults, while GFCI protection protects against electrical shock caused by ground faults. By understanding the principles of AFCI and GFCI protection and following the guidelines of the National Electrical Code, it is possible to create a safe and reliable electrical system. The correct selection of AFCI breaker size depends on several factors, including the power consumption of connected devices, the length of the circuit, the type of load, and the requirements of the NEC. By carefully considering these factors and consulting with a qualified electrician, it is possible to choose the appropriate AFCI breaker to ensure electrical safety and prevent nuisance tripping. In summary, determining the appropriate amperage for an AFCI breaker requires a thorough understanding of the circuit's load, the length of the run, and applicable electrical codes. While 15 amp and 20 amp AFCI breakers are common, situations involving high power equipment, long circuits, multiple appliances, mixed loads, or heavy-duty applications may necessitate higher amperage ratings to ensure safety and prevent nuisance tripping. Always consult the NEC and a qualified electrician for proper installation and sizing. Remember that electrical safety is paramount, and proper overcurrent protection is crucial to preventing electrical fires and ensuring the safe operation of electrical systems.